My name is Malcolm Macleod, and for my master's project, I established two citizen science programs to monitor and assess Tomichi Creek on Cold Harbor Ranch. Upon becoming a Cold Harbor Fellow, there was an express need for a water management plan to guide development on the property. However, after consulting with professionals in the water world, it was made clear that a comprehensive stream assessment was a necessary first step to informing such a plan. Cold Harbor Institute also had a need for moving towards a more sustainable approach to water quality monitoring. I chose citizen science as the way to address both of these organizational needs. Citizen science is the process of engaging community members in collecting and analyzing scientific data. For the baseline study, I started a program that engages volunteers in collecting all of the necessary field data for a full stream assessment. I also established a partnership with Riverwatch Colorado to ensure that Cold Harbor Institute has long-term and financially sustainable water quality testing. This is Cold Harbor Ranch. This part of Tomichi Creek is unique because it's where it comes together with Cochetope Creek. It's also interesting because the floodplain is constricted by human development, including a highway and a couple of railroad grades. Before starting assessment, I took this stretch of Tomichi and I split it into 5 study reaches. In 2019 field season, we collected data on reaches 1 and 2, the area you see highlighted in gold. The established method for conducting a stream assessment in this region is to use the Colorado Stream Quantification Tool. This tool provides an in-depth assessment of a stream's current condition, information that Cold Harbor can use to determine the restoration potential of the stream and how far it is from its historical trajectory. 2019 was the first year that we collected field data for this study. This field season engaged 18 volunteers in measuring stream features. This included teaching them to use survey equipment such as a laser level to determine the elevation of stream features, along with measuring the width of a stream compared to its floodplain. We also took depth measurements along each of the 18 transects. All of the field data collected in 2019 is necessary for assessing floodplain connectivity. However, the stream quantification tool has various other parameters that all need field data collected for. The most challenging part with this program was realizing that the scope of the study went well beyond any single MEM project. However, this has opened up the door to future projects, such as 1 to 2 to finish collecting the data and run the stream quantification tool for all of the reaches, and potentially also another to do an in-depth assessment of the riparian vegetation, which would also help inform wildlife management. These scientific studies could be conducted either as other MEM projects or by MS in ecology students. Eventually, once a baseline study is complete, there will be another project that actually writes the water management plan for Cold Harbor Ranch. Cold Harbor had been monitoring the health of Tomichi Creek on its property for 20 years using USGS water quality testing. However, this method was getting increasingly expensive and only tested a few times a year, so we started a local Riverwatch chapter. Riverwatch is an established citizen science program whose data is used to inform water management throughout Colorado. Riverwatch has strict quality assurance protocols that ensures the validity of our field data. Getting our water quality tested through Riverwatch saves Cold Harbor Institute at least $8,000 a year, and on top of that, engages community members in collecting water samples and testing them for chemical parameters on a monthly basis. Cold Harbor now has 2 water quality monitoring stations. One of these stations is at the west end of the ranch. This monitors the water quality as it exits the property, and it's tested on a monthly basis. The other station is right below the confluence with Cochetope, and this monitors the water quality as it enters the property. This one's tested on a quarterly basis. Riverwatch tests for various parameters. Chemically, we look at dissolved oxygen, pH, hardness, alkalinity, 13 different metals, nutrients, and total suspended solids. Physical parameters we test at sampling events include temperature and flow, and soon we will start sampling macroinvertebrates as a biological indicator. Another important part of my project is that it started the process of mapping out Cold Harbor Ranch. With the help of Dr. Crossley, we flew a drone over the stream survey study area. This resulted in over 600 images which were put together into this map. The resolution looks fuzzy, partially because of the scale, partially because there's snow on the ground. Here's a zoomed in photo to show you its actual quality. This process taught me how to manually stitch images together into a cohesive map. Ultimately, however, I opted to use Maps Made Easy software because it produced a digital elevation model and a simulated laser point cloud. I used the resulting maps to verify my field data and made profile graphs at each transect since this was useful in comparing relative elevation data I gathered in the field with actual elevations for stream features like the bank full and channel heights. The laser data map is quite striking because it so clearly shows elevations for different features. Here we see tall vegetation in red, deeper parts of the creek in darker blue. The floodplain is highly visible, and so are other features such as the irrigation ditches that wouldn't be as much in normal satellite imagery. It's important that Cold Harbor takes this as a model and scales it up for the entire property. Besides its obvious application for water management, having this kind of data for the entire property would help resolve many of the existing research questions and would definitely open up the door for many more. Another project that's worth mentioning is non-lethally resolving conflicts with beaver by building flow devices. After a community assessment of Gunnison revealed there was a need for this, I enrolled in a flow device certification course with Beaver Institute to learn how to better promote coexistence with beaver while mitigating damage to property. The flow device you see here is at the Aberdeen Quarry, where a massive dam was spilling over and flooding out the ingress road. With the help of friends, we established this pipe system that controls the water level, making it so that the water no longer floods out the road, but that there's still at least 3 feet of water in the pond to keep the beaver happy. The cage at the intake of the pipe makes it so the beaver does not recognize the source of this permanent leak in their dam. The first flow device I built was a trial and error process. It started off as a culvert protective fence. However, I built it before having had any training and therefore didn't install it with a floor. This made it so the beaver was able to dig underneath, get inside, and start plugging up the culvert again. However, by the time that I realized it was already almost winter, so I went back up and used the materials at hand to build a skirt along the perimeter of the fence so they couldn't get in underneath. However, this weakened the structural integrity of the flow device and it did not withstand winter. That's why I'm going back next week and building a fence and pipe system. After finishing my training, I feel confident that this is the best solution for this site. As opposed to the protective fence that tries to prevent beaver from damming, this structure encourages beaver to dam along the fence and then uses a pipe system to control the water level, keeping the culvert free of debris and the road free of water. But this is all to show, though, that in implementing innovative approaches to land management, sometimes multiple attempts are necessary to succeed. Here are some references. Now, I want to give a huge shout out to everyone who's represented on this list. Thank you for your role in helping make this project a success. Especialmente quiero decir feliz cumpleaños a mi mamá. Si no era por el apoyo de mi familia, nada de esto sería posible. In summary, what this master's project accomplished is starting the process of using a drone to map out Cold Harbor Ranch, establishing a citizen science program to do a full assessment of this stretch of Tomichi Creek, started a River Watch chapter to have long-term and sustainable water quality monitoring. It taught people about how to coexist with beaver by building flow devices. And all of these projects have a really bright future for continuation. In the following year, Jesse Bryan, another Cold Harbor Fellow, will be administering and expanding both of the citizen science programs. Later on, a Cold Harbor Fellow will finish mapping out the entirety of the property using high quality imagery. And eventually, someone will use all of our work as a foundation for developing a water management plan for Cold Harbor Ranch. As for myself, wherever this path may lead, you may rest assured that I will continue to work to help heal impaired natural systems and to advocate for coexistence with beaver for a more resilient future. Thank you very much. I will at this point take questions.